Hi everyone. Let's continue to Chapter 5, Groundwater Pollution. What is the definition of groundwater? Groundwater can be defined as water located beneath the Earth's surface, in soil pore spaces, and in the fractures of rock formations. Groundwater is recharged from, and eventually flows to the surface naturally. Natural discharge often occurs at springs and seeps, and can form oases or wetlands. Groundwater is also often withdrawn for agricultural, municipal, and industrial use by constructing and operating extraction wells. Groundwater is thought of as liquid water flowing through shallow aquifers, but technically it can also include soil moisture, permafrost, frozen soil, immobile water in very low permeability bedrock, and deep geothermal, or oil formation water. Groundwater is hypothesized to provide lubrication that can possibly influence the movement of faults. For example, landslide. This figure shows the layer where the groundwater occurs. Normally the water is extracted by using a well. Aquifer is an underground layer of water-bearing permeable rock, or unconsolidated materials consist of gravel, sand, or silt, from which groundwater can be extracted using a water well. The depth at which soil pore spaces or fractures and voids in rock become completely saturated with water is called the water table. Confined aquifer is an aquifer that is overlain by a relatively impermeable layer of rock, or substrate. If a well is drilled into this pressurized aquifer, the internal pressure might be enough to push the water up the well, and up to the surface without the aid of a pump, and sometimes completely out of the well. This figure shows how the groundwater is formed in the aquifer, and normally from higher to lower regions. Groundwater is extremely important to our way of life. Most drinking water supplies, and often irrigation water for agricultural needs, are drawn from underground sources. Hot groundwater can also be a source of energy. But this energy is not so popular in Malaysia. Where is the source of groundwater? Groundwater is derived from precipitation falls that percolate downward from the surface. It collects in the open pore spaces between soil particles, or in cracks and fissures in bedrock. The process of percolation is called infiltration. This figure shows types of precipitation around the world. In Malaysia, the major source of groundwater comes from rain. What are the factors affecting infiltration? The greatest factor is precipitation. The precipitation is dependent on the magnitude, intensity, and duration. Besides that, the precipitation characteristics such as rain or snow. This figure shows the process of precipitation that enters the groundwater. The second factor is the soil characteristics. Clay-type soil absorbs less water at a slower rate than sand. This figure explains why the clay-type soil absorbs less water, due to the smaller pores compared to the sand. The other factor is soil saturation. Higher saturation leads to more runoff instead. Normally, clay-type soil is more saturated compared to sandy-type soil. The clay-type soil can hold water longer, and that is why the soil at the paddy field is muddy type. Normally, the sandy soil consists of less saturated gravel and only holds water for a short period. Land cover also affecting the infiltration process. If the area is an open area with no vegetation, less water can be settled down at the groundwater. However, if the area is a forest ecosystem, more water can reach the groundwater. Besides that, the slope of the land also affecting the infiltration process. Hills enhance runoff velocity, which mean that less water is absorbed by the soil. Evapotranspiration. Plants usually in agriculture areas use soil moisture to grow and transpire. Groundwater is relatively clean because it is mixed and circulated over a large area. But the increased population and industrialization of the 20th century has led to serious groundwater contamination problems in many parts of the country. For example, farming or agricultural practice contaminants include pesticides, herbicides, animal waste. Water pollution of groundwater, from pollutants released to the ground that can work their way down into groundwater, can create a contaminant plume within an aquifer. Movement of water and dispersion within the aquifer spreads the pollutant over a wider area, its advancing boundary often called a plume edge, which can then intersect with groundwater wells or daylight into surface water such as seeps and springs, making the water supplies unsafe for humans and wildlife. Most compounds form a contamination plume in the groundwater that grows wider as it spreads outward from the point of contamination, called the point source. If the plume is flowing through sand, a portion of the contaminants are naturally filtered from the groundwater. Even though the plume widens downgradient, the concentration of the contaminants tends to decrease through filtering, dilution, or the natural breakdown of substances. For your information, soil is one of the best water natural filter systems. This figure shows what happens to the pollutants once they enter the groundwater from a point source. After reaching the groundwater, the pollutant will be spread. And normally, the pollutant will be diluted by water once they reach the groundwater. Variety of contaminants from city and county dumps such as heavy metals and other industrial compounds enter the groundwater from rainwater that has percolated through the landfill. Wastes from septic tanks and sewage plants may also contribute dangerous bacteria and parasites to the groundwater. How frequent your septic tank is clean up? Once in 1 year? Or never? This figure shows the common scenario, if the house owner using groundwater extracted from a well. Do you notice where the septic tank is? What is the depth of the septic tank? If the septic tank is overflow, where the waste will settle down? Industries frequently use radioactive compounds, cyanide, polychlorinated biphenyls, and a degreaser called trichloroethylene that are being found in increasingly greater amounts in groundwater. Gasoline and other fuel derivatives such as xylene and benzene are carcinogens that frequently enter the groundwater from leaking storage tanks. For example, the petrol station, they also build the tank underground. If the tank is leaking, the petrol will enter the groundwater. Example of case study. Love Canal, New York. The neighborhood noticed high rates of cancer and an alarming number of birth defects. Eventually traced to organic solvents and dioxins from an industrial landfill that the neighborhood had been built over and around, which had then infiltrated into the water supply and evaporated in basements to further contaminate the air. "800 families were reimbursed for their homes and moved, after extensive legal battles and media coverage." The another example is in Ganges Plain, India, and Bangladesh. The pollution occurs because aquifer sediments contain organic matter that generates anaerobic conditions in the aquifer. These conditions result in the microbial dissolution of iron oxides in the sediment and thus the release of the arsenic, normally strongly bound to iron oxides, into the water. As a consequence, arsenic-rich groundwater is often iron-rich, although secondary processes often obscure the association of dissolved arsenic and dissolved iron. That's all for this chapter. Thank you. Have a nice day.